Hi everyone! For this series of videos, we're going to talk about vectors. So let's start with the introduction. Okay, when we say vectors, we only need to remember two things. Vector has a direction and a magnitude. So quantities that have direction and magnitude are velocity, acceleration, force, momentum, are just example of vector quantity. Now, the other quantities like temperature, the distance, speed, these are not vectors because they don't have a direction. They only have a magnitude. So we call these quantities as scalar quantities. They are just numbers. Now, how are vectors represented? So vectors can be in 2-dimension or 3-dimension. So if we have a 2-dimension vectors, then we can graph that in an XY graph. And if we have a 3-dimension vector, then we can graph that in a XYZ graph. Okay? So this is our X, Y, and Z. So I just turn it. Okay? So vectors are represented by an arrow. So it can be this or this. And for 3D vectors, it can be represented something like this. So this is for X, and this is for Y, and the Z is like going up. So we can represent that. So the vector would be the point from this direction. Oops. It's like the vector is going out. There you go. So as you can see from our 2D vectors, we have the X and Y components. And for our 3D vectors, we have the X, Y, and Z components. Now, how are these represented? So in some books, they represent it using the coordinates. So for 2-dimensional, let's call this vector A, and they will represent that as something like this. Let's say 3 and 2. So this is your X component and Y component. So if we have a 3D vectors, so the vectors, we have the X component, Y component, and let's say 4 as our Z component. Okay. Also, it can be represented with an arrow to show that it is a vector. And sometimes they use this notation. So for 3D, we can write that as 3, 2, 4. And another representation is using this symbol. So whether they use this symbol or the with the arrow, it's all the same. I'm just showing you how different books or different questions may look like, but it's all the same. Let's try to focus on two-dimensional vectors. So for example, let's call our vector A, and has a component of 3 and 2. Okay, this can also be written as this way, 3, 2. So just remember, this is our x and y component, and if it's written vertically, this is our x and this is our y. So our vector, so our x is 3 and y is 2. So this is our vector A. Now let's say we have vector B. Let's say our vector B has an x and y component of negative 3 and 4. So again, if it's written vertically, the first number is x, the second number is our y. So how will that look like? So this is negative 3. Okay, let's make it longer. So negative 3 and 4. There. So what do these vectors tells us? So the x and y component of vector A tells us the direction, and same thing goes with our vector B. The x and y component is the direction, like it goes negative 3 or 3 units to the left and goes up 4 units. So that's the direction. Now what about the magnitude? So to calculate for the magnitude, we also need to know the term. Another term for magnitude is the length. And they use the notation or symbol for magnitude or length as the absolute value symbol. So if you see something like this, it means you're asked to find the length or magnitude of vector A. Or it can also look like, they also use this like double parallel line. So there. Okay, so let's pull out the vector A. So we have the x component 3 and y component 2. And this is our magnitude or the length A. So as you can see, it is a right triangle, and our length or magnitude is our hypotenuse. So we can use Pythagorean theorem. So to calculate for the hypotenuse, so that's h squared is equal to a squared plus b squared. So our hypotenuse is the length or the magnitude squared is equal to 3 squared plus 2 squared. So the length is equal to the square root of 9 plus 4. So the magnitude is equal to square root of 13. Now let's try vector B. Calculate the length or magnitude of vector B. So we have here the x component and the y component. Okay, so this is our magnitude of vector B. So let's calculate. So that's length of B squared is equal to -3 squared plus 4 squared. So this is length of B is equal to the square root of 9 plus 16. So the length of our vector B is equal to square root of 25, or that is equal to